Hi everyone, welcome to DigiPharma YouTube channel. In this video, we are going to discuss about the mass spectrometry. Mass spectrometry represents the measurement of molecular weight of a compound. So mass spectroscope is a one type of analytical technique where we are determining the molecular weight of a given sample. Whether the sample is a small molecule or larger molecule, we can easily identify the molecular weight of the compound with precision and accuracy. In this spectrometry technique, we are does not involve the absorption or emission of light. There is no light source will be present in the spectrophotometry, and this is the only the spectrophotometry technique where we are not using the light sources. In this mass spectrometry, the compound in the gaseous state is bombarded with a beam of electrons to produce the molecular ion. So the molecular ion's molecular weight is determined. Sometimes this molecular ion will be further fragmented. So the fragments molecular weight also identified by using this mass spectrometry. So in this mass spectrometry, at the end, we are getting the one spectrum. That spectrum is called as mass spectrum. In this mass spectrum, the x-axis is represented with the m by z ratio or m by e ratio. That is nothing but mass by charge ratio. And y-axis is represented with the relative abundance. The principle involved in the mass spectrometry is, so we are dividing into the 4 steps. In the first step, the sample should be introduced in the instrument in the gaseous form. So from the sample source, the compound or the molecule, whether it is in solid form or liquid form or any other form, first we have to convert into gaseous form. The gaseous form molecules are The gaseous form molecules are entered into the ion source or ionization source, where the gaseous molecules are impacted or bombarded with the high energy electrons. So in this direction, the high energy electrons are coming. Now these high energy electrons are bombarded with your gaseous molecules. So this is your molecule, and from here the high energy electrons are coming. So when these high energy electrons are bombarding with the your molecule, so from this molecule, one electron will be removed. So that's why the molecule will be converted into the molecular ion. And sometimes, so this molecular ion will be fragmented into different fragments or further divided into fragments. So these fragments are called as daughter ions or fragments. So whatever the fragments and molecular ions are formed, now they are passing through this your ionization source. So in the ionization source, when it will coming out of the ionization source, we are placing the accelerator slits or electrostatic accelerator plates. Now this electrostatic accelerator plates will be improve the movement, or it will be increase the velocity of the formed molecular ions or fragment ions. Here the applied electric voltage of the your molecule accelerator potential directly proportional to the kinetic energy of your molecule, that is nothing but mv square. So why? Because these positive potential or accelerator electrostatic potential will equal to the kinetic energy or velocity of the molecular ions or fragments ion. So once the molecular ions or fragment ions are moving through the electrostatic field, then they will be entered into the magnetic sector or magnetic field. So where the fragments or the molecules will be follows a different curvature paths. So based on their molecular weight or their radius. So here they will be follows a different curvature paths. They will be follows different curvature paths. So when they will be follows curvature paths, they will be travels in the different distances. They will be separated. The fragments and the molecular ions are separated based on their mass by charge ratio. Here, once you see here. So once when they will reach the magnetic field, they will be follows different mass by charge ratios. So here that time Just I'm roughing this one. Yes. Now, so based on their different radius, they will be follows a different curvature paths. So here, the magnetic strength, it will be represented with the HeV. It will be directly proportional to the, so here what happened, the molecular ions and the fragments are following the radius path, nothing but it will be nothing but your centrifugal force of your molecule. So the first is the your applied electric potential directly proportional to the your kinetic energy of the molecule of mv square. So when you simplify these two, we will get you one equation. We will discuss in the next slide. So they will be travels a different uh, curvature paths, and here they are separated with their distances. So the molecules which will be follows a larger curvature paths, they will be slowly travels. Which will be follows a lesser curvature paths, they will be reach the analyzers in a short period of time. So the molecular weight of the molecule which will be follows a lesser curvature path is identified by the or analyzed by the mass analyzer first. So which is follows a larger curvature or larger radius paths. So they will be reach the analyzer, mass analyzer in the where it will be takes more time to reach your mass analyzer. So though in this way the molecular ions of the different fragments and the molecular ions will be determined. So here I have given the two equation, EV is equal to half mv square, H is equal to half square. So here the positive potential energy of kinetic energy of the molecule equal to EV is equal to half mv square. And here the applied magnetic strength is directly proportional to the your centrifugal force of the molecule. So when you simplify these equations, we will get one equation EV is equal to half mv square. Means the when we simplify this one, by using these two equations, we are getting m by e is equal to h square r square by 2v. So h is the magnetic strength and v is the applied potential. These two are constant. So means directly the m by e is directly proportional to the your radius of the molecule. If the molecule will be having the high radius or larger size, they will be travels a larger curvature path. So if they are having the less radius, they will be follows a lesser curvature path. So these molecule will be reach the analyzers in the short period of time. So these molecules, the higher curvature path will be reach the analyzers in the larger. It will take so much of time. So this is the principle involved in the your mass spectrometry. So thank you for watching this video. In the next video, we are going to discuss about the instrumentation of mass spectrometry.